factoring trinomials of the type ax squared plus bx plus c, where the leading coefficient a is not equal to 0. We say that this trinomial can be factored in two linear factors if we can write in this way. Ax plus p, that's one factor. Another factor is ax plus q. These two coefficients, a comes from this leading coefficient, and let's talk about p and q. If a times c, that's the product of leading coefficient and the constant term, if it equals to p times q, that means we are able to find those two factors such that their product equals to the product of leading coefficient times constant. And if p plus q equals to the middle coefficient, that's b. In this situation, we say that this trinomial ax squared plus bx plus c can be written as a product of these two linear factors. Now, if everything remains same, if this first condition remains same, but we are unable to figure out or find two numbers p and q such that p plus q is not equals to b. If we are unable to do so, then we say that this trinomial is not factorable by this method, okay, by using these two linear factors. So in this situation, we say that the trinomial is prime. Let's take an example. 2x squared plus 7x plus 3. A is 2, b is 7, 3 is c. So first, let us multiply a and c. That is 2 times 3, which is 6. Okay. Now we would like to find two factors of 6 such that their sum will result to 7. How can we get or find those two factors? Is we can write in this way: 6 times 1. 6 times 1 is 6, and 6 plus 1 is 7. So this is p and this is q. All right, so it's fairly straightforward. Then we can write in the way that we have previously mentioned, that is 2x plus p is 6, and 2x, you write it down, and then q is 1. 2x plus 6, 2x plus 1. Those two are our factors, okay? But we are not done yet, right? Since you can see that in the second factor, we don't have anything common in between these two terms, okay? But in first factor, we have something in common in between these two terms. Those two common factors are, we know that 2 is common in between 2x and 6. So let's pull that 2 from both 2x and 6, which gives us 2x plus 3, since 2 times 3 is 6. And nothing changes here, 2x plus 1. I would want you to ignore this common factor 2. Okay? Just ignore it. So our factorization would be x plus 3. Okay, so that's our total factorization. Now we are not still done yet. We need to check whether these two factors gives us this result or not. Let me ask you, why did I ignore this 2? Okay, that's a question for you. If you want to really know why did I throw this 2 away, is solve this equation. Solve this. Then you'll clearly understand why we can throw this away. Okay, let us try to check whether these two factors, when multiply, gives the original quadratic expression or not. I have copied down these two factors as they were. Now let us multiply these two binomials. Okay, Now first let us choose x and multiply it with 2x. So that will give us x times 2x is 2x square. Again x multiplies with 1. So x times 1 is 1x. That's simply x. We have multiplied x with both 2x and 1. Now it's the turn of 3. Let us multiply this 3 with 2x at first. 3 times 2x is 6x. 3 times 1. 3 times 1 is 3. So that's plus 3. And don't forget to check your signs repeatedly. Okay? We might be confused with negative signs. So now finally we can write this as 2x square plus x plus 6x. That's 7x plus 3. It matches and it's exactly the same quadratic expression. Okay, so this is true. So our factorization is correct. This is very simple way to factorize a quadratic expression. And this method can be used to solve quadratic equations. Another example, 4x square minus 17x plus 15. Okay, here also let us multiply 4 and 15, the leading coefficient and the constant. So that is 4 times 15. I can write the prime factors of 4 is 2 times 2 and prime factors of 15 is 3 times 5. Now out of this form we want to come up with two numbers from these factors, okay, such that their sum would be 17. Okay, let's ignore this negative for a while. Okay, I want 17. So what would be the good choice, right? So this would be 2 times 2 times 3, that's 12 times 5. 12 times 5 is of course 4 times 15. That's true. So I will go for 12 times 5. 12 plus 5 is 17. But we know that we need a negative sign in front of it. So how can we handle this? But having negative sign in here really causes a trouble, but not so much, since this is a positive number. 4 times 15 is a positive number. But we know that negative times negative is a positive number. So why don't we write in this way? Negative 12 times negative 5. So you can easily realize that negative 12 plus negative 5 is negative 17. That's correct. And also negative 12 times negative 5 is again 4 times 15. So we get rid of the trouble in this way. I hope you understood this. Okay. Now let's write down the linear factors. 4x leading coefficient times the variable minus, since plus times minus is minus, so that's 12, and 4x again, that's ax minus 5. Now you can see here the first linear factors, the both expression has something in common. 4 is common in between 4x and 12. So let's factor out the common terms, which is 4. 4 times x is 4x, 12. 4 times 3 is 12. And this is 4x minus 5. By now, I think you might have already realized why we can ignore this 4. Okay? I gave you some hint, and also I gave you the multiplication backward checking just to illustrate my case. So our complete factorization would be x minus 3, 4x minus 5. Okay, so that's the factorization. And now it's your duty to check whether I correctly factorized the trinomial or not. So that's all.